Hey folks, this is Shane from Performance EV. Welcome to our latest video. Why don't you join us today while we look inside the inverter from the Nissan Leaf drive unit. Okay, so here it is, the heart of the Nissan Leaf drive unit. This is the inverter which takes the DC power from the battery and converts it into AC power from the motor. We've got three main contact points: the DC power coming into the inverter, AC power going back out, and the various signals coming from the ECU and motor to help the inverter figure out what to actually deliver through these three contacts. The inverter sits like in this orientation in the drive unit itself. This plate here effectively forms the base of the inverter, so we're going to flip it over so we can access the bolts to undo it. Alright, now we've got this flipped over, we're going to start undoing the 12 10mm bolts around the outside and disconnect this connection point. Here we've got the signal wires going into the inverter, coming from various points from the ECU, from the motor itself, giving it the necessary information it needs to decide how much power to give to the motor. So there we have it, the inverter for the 2014 Nissan Leaf. So let's take a look inside and see what it's made up of. Just want to take a quick look at the components that actually make up this inverter. So right here we've got, I guess, the brain of the unit. This is the logic board that takes the signals from various different sources, the ECU, the motor itself, or even from inside the inverter, and converts them into the signals that instruct the other parts of the converter. So behind it, down at the very bottom, you've got a large circuit board there that contains the three IGBT driver circuits and the additional monitoring and sensing circuits there. Above it, you've got a nice big capacitor, and then down here you can see the IGBTs themselves and the two current sensors. And then over here on the other side we've got the bleed resistor for discharging the capacitor when the power is switched off. So in terms of how things flow through this, from a power perspective, when the vehicle is switched on, power is fed in through here into the capacitor, bringing it up to the voltage of the battery, and that's stored there ready for the signals that are going to come in through here for the from the ECU. So that includes signals like the position of the throttle pedal, telling how much torque to provide. Those signals are processed by the logic board, and they'll then be sent down through this connection here, which houses a 5-volt power, and then the high side and low side PWMs from to control each of the individual IGBT driver circuits. So those will take the DC power that's flowing in from the capacitor to one side of the IGBT and convert it into one of the 3 phases of power that's being sent back out. So each of these IGBTs has a nice big connection, and those come out of each of the 3 connections here. The current sensors then monitor the flow of power that's going through these and feed that back to the logic board. And likewise, we've got a connection here that takes the data from the various monitoring within the driver and again feeds it back to the logic board. And then any changes made on what level of power needs to be delivered to the motor will be sent back to the driver circuits. Right, in order to make this easier to work on, I'm going to try and disconnect the inbound DC bus bars that go to the capacitor, just to so we can set it flat to make it easier to work with. So the other element of the drivetrain that we're going to have a brief look at in this video is the motor itself. I'm not actually going to strip this down because while I'm comfortable playing around with electronics or mechanical things, permanent magnet motors are a little bit beyond my expertise at the moment. So we're going to leave this intact, and it's going to be more with the signals going into it that we'll be doing things. So this is the EM57 motor unit. Produces about 80 kilowatts and is, as you can see, liquid cooled. We would have seen that when we did the teardown, taking off the coolant pipes. Not that much by way of connections on it. Obviously you've got the physical connection of the output shaft, the spline shaft, which usually goes into the center of the reduction gear. This particular unit, I think, runs up to 10,000 RPM, so that can spin pretty quickly. In terms of signals, the main one that comes out of here is through this connection here, which is to the resolver. So that tells the inverter exactly what the position of the rotor is within the electric motor. And then we've got the power connections. So this is where the 3-phase AC is going to come in. So let's look at the inside of a Nissan Leaf Inverter. I hope you got something out of it. I will be doing another video where we go a little bit more in depth and take some of the components apart lift them out, see what sits underneath them, which will be coming out soon. And after that, we're going to start trying to get power and data running through this. So I hope you've enjoyed today's video, and if you did, please like it. If you're not subscribed, please subscribe if you want to see more of this sort of stuff. And yeah, if you want to click the notify button so you find out when we release new videos, go for it. But thanks for joining us today, and see you next time.